Circle.
The last part.
But when I was walking around the room, you know, we still have graphing issues from last year. That's what it is. Okay, let's do this quickly so maybe we can watch the movie a little while. Probably not though. Hey, what do we got here? What do you got? Number 27. Boo! Get ready to get booed. Okay, so the key in computing an integral is to know the antiderivative. Okay, we'll just start with Lamachane. Antiderivative of this. Read it off your paper.
You see, it's an odd number.
And I was going to write a letter of recommendation for you. I laugh at that. Okay, just look at it and do it. This is easy.
So 2x.
2x minus. And we did
ln x.
Very good. Natural log x.
Oh, C stop one.
Do I need to put the plus c?
No.
No,
Plus
because
C.
we know it cancels out, but you better know it's there now. Because if you don't know it's there, then I'm not going to let you not write it.
Yeah.
Okay, plug in the top number. 6 minus natural log 3 minus, now plug in the bottom number. 1 minus natural log half. And can I leave the simplifying to you?
Yes.
So the problem with that problem is we didn't know the antiderivative of 1 over x. Even though it came up in class. Okay. Woo! 28. What kind of 8 is that? Who writes an 8 like that? Was that you? Abe? I guess it was. No, we did this last time too! Why do we even have
I
class?
just wrote the number. I thought suggestion.
Why do we even have class? Ishihara, what's the antiderivative of 3 to the x? In fact, did I ask you that last
Yeah,
time?
you did.
Who was it? Oh, was it Trent? Let's give Ishihara's turn. Antiderivative of, no, I remember.
3 to the x ln 3.
Yeah.
Close, but no cigar. 3 to the x
ln.
over ln 3. Now, do we have to discuss why that is again? Okay, I will. Okay, look. If I take the derivative of this, why do you get that? Because this is a constant, so you throw it on the side. And what's the derivative of 3 to the x? 3 to the x times ln 3. See how this thing cancels out the ln 3. Thought we discussed that last time, right? I know I was right. Now, does this bother you that the smaller number is on the top?
You shouldn't.
It shouldn't bother you. But if you want to reverse the limits just to feel comfortable, then you got to negate it, right? But it doesn't matter. Plug in the top number. Okay, I'll do it. 1 over 3 ln 3 minus, now plug in the bottom number, 9 over ln 3. Can I leave the simplifying to you?
Yes.
Yes.
Now, once you get to this step here, you only can lose 1 point already at the most, because that's the correct answer. But of course, on the AP exam, this would be full credit. But I want you to simplify it because you need to pick out the answers on the multiple choice. Number 39. Really not? Oh, okay. Integral from -1 to 1 of r plus 1 squared dr. Now, do you know why they're giving you these other variables, r, theta, like that? To prepare you, to prepare you for polar coordinates. What do you mean, no thank you? That's the next step. See, you're computing areas like this, right? But then what about polar graphs? You guys remember polar graphs? Remember the rose curve? Like,
Facing to the
we're
right.
gonna actually compute the area of like the rose curves and things. Easy. Okay, now look at this.
I think I'm good.
Okay, you guys think you're good?
Yeah.
Okay, the antiderivative of this, can I just think of it as box squared? So can I just go box cubed and put a 1/3 in the front? Does that work?
Yeah.
Can I? Does that work?
Yeah.
Yes, it does. You know why? Because the derivative of the box is 1. Oh, so you can do. But what if the derivative of the box is not 1?
And you gotta make it 1 over
Then
3
you gotta
times.
adjust it. Yeah, exactly. So, -1 to 1. Of course, if you didn't see that, can you just multiply it out then and do it? Yeah. It doesn't matter. Just do correct mathematics. Plug in the top number.
Michael.
8/3.
8/3 minus plug in the bottom number. I'll try 0.
Oh.
I will leave the simplifying to you.
I'm trying to simplify that.
We cannot simplify that.
Oh, that's 8/3.
16.6.
Your GPA. Whoa! You guys can't handle the truth, yeah? What? Minus root u over root u.
This is the part you're on fire.
What?
You're on fire.
I'm on fire.
Yeah.
Okay, what do I do here? Come on, I tried to teach you this from the beginning. What do you do when you see a single term in the denominator? Lift and separate. Or what are you guys doing? You know when you do integrals, you gotta at least try something, you know. Some of you, I think this is what you're doing. I'm just gonna write it on the board, come on. Or, and the other half of you, I'm looking at it for the first time now.
Wait, he got us.
I know I got you.
Got us.
Okay, so if I lift and separate, what is 1 over radical u? No, u to the negative half. You want to prepare it for antidifferentiation.
Antiderivative.
What is root u over root u? Plus 1. Okay, so what is the antiderivative, Hanuman? Make the power 1 bigger. So what do I need in the front? So when I put down the 1/2, it cancels it out. Okay, minus? No, because the, okay, u. See, this thing means something, that's the independent variable. 4 to 9, and please don't write 9 to 4, it's 4 to 9. I think I ranted on that last time, yeah? Plug in the top number. 6 minus 9. Plug in the bottom number. 4 minus 4.
I like this part.
Hey, Mr. Park! How come the answer comes out negative? Why would this answer come out to -3? Well, maybe most of the graph is below the x-axis, that's why, right? So yes, integrals can be negative if most of the graph is below the x-axis. 41 and 43, really? Okay, you know what, I'm just gonna do 43. 41 is just too simple. How about just draw a picture, just like today's quiz, yeah?
Which part?
Yeah.
I plugged it into my calculator and it was like a different answer from the back.
Who said to plug it into your calculator?
No, because I got an answer because it was simple.
Okay,
But
here,
then, like,
let's just do 41. It says from 0 to 3. Okay, can I just do this? Can I just go? Now, the direction says, find the total area of the region between the curve and the x-axis. Can I just do this? Oh, so easy. Integral 0 to 3 of 2 minus x dx. Well, you can tell from the tone of my voice, no, you cannot. You know why? Because some of the graph is below the x-axis and some of it is above. So if you draw the graph, what does the graph of 2 minus x look like? Like that, right? So from 0 to 3, look, if you did it, okay, what's this area right here? What is 1/2 2 times 2?
1, 2.
2. 2. And what is that area there? 1/2 1 times 1? 1/2.
Negative.
So if you did an integral from 0 to 3, just like today's quiz, what would the answer be? Because since it's below the x-axis, it's going to be negative, it counts negative. So wouldn't the answer be 3 over 2? But that's not the question they're asking. They're asking what is the total area between the graph and the x-axis. In other words, they're asking what is this area plus that area? The answer is 2.5. But if you did an integral from 0 to 3, you would get 1.5. You guys see the difference between the two things? Okay, so let's do 43 now. So it says, find the area between this graph and the x-axis from -2 to 2. So what you should do is you should kind of sketch the graph so you know what's going on. So how do I draw this graph? Factor out an x squared minus 4. In fact, let's factor it all the way. And this is a cubic equation, leading coefficient positive, so it's going to be Okay, did we get a graph that looks like that? Wait, one more second. Yeah, now I got it. So they want the total area. They want this area plus that area. Now I didn't draw it accurately because, can you say, but don't look at this picture, can you say that this area is congruent to that area? Yes. In the region? How do you know for sure?
Because it's an odd
This is
function.
very good, it's an odd function.
Ramen.
Sit down.
Oh, okay.
Sit down. Sit down.
Dang, but that was so good.
So, if you are smart, why not just find the area of one of these and then just times it by 2?
So you put the problem for the first one?
Okay, so which area do you want to compute? A or B?
B.
A.
B.
C.
Okay, let me ask, okay, if you compute A, then your integral is going to go from -2 to 0, right? If you compute B, it's going to go from 0 to 2.
0 to 2.
Now, do you really think that you can plug in -2 without making a mistake? C?
Yeah, you have to go B.
Okay, let's do it then. We're gonna do A or B?
B.
Okay, integral from 0 to 2 of f of x dx. Now, is this answer gonna come out positive or negative?
Negative.
It's gonna come out negative because the graph is below the x-axis, but this is gonna adjust for that. Okay, so antiderivative, that's easy. Whose turn is it? Tran, antiderivative. Read it off your paper.
1/4 x to the 4th
I don't hear paper crinkling.
minus 2 x squared.
Okay, good.
Hey,
From 0 to 2, plug in the top number, 4 minus 8 minus 0 minus 0, you get -4. Now that negative just means it's below the x-axis, so what is this actual area? It's 4. Remember, area cannot be negative. There's no such thing as negative area, but the value of an integral can be negative. So if this area is 4 and that area is 4, what's the total area? 8. Now some of you thought, hey, this problem is just simple, I just do an integral from -2 to 2. In fact, what would happen if you did an integral from -2 to 2? You would get 0. Change, which is not correct. So that's why I assign these problems to make you think. Now tonight's homework, you got,
Let's
Okay,
watch the movie.
let me just show you a problem that you're gonna get on tonight's homework. Are we done?
Yes.
Okay, good.
Let's watch the movie.
No, I'm gonna show you a problem because I know already, because if I don't show you, like, at least how to get started on it, some of you just gonna say, I'm just gonna write it on the board.
Yeah.
I don't know what to do. See, you guys are not struggling, you guys are BC. The BC stands for something.
Wait, AB has practice
Best
quizzes?
calculus
Our best class.
students.
Best calculus students.
Best calculus teacher.
Now, I'm gonna tell you right now, this problem has been on the AP exam on the free response the last 5 or 6 years, so it's gonna be there.
So this year.
So what they're gonna do is they're gonna give you a graph like this. So let's say it's a semicircle, and then you have a line. Okay, this is good enough. Okay, here's the point 4, 2. Okay, so this graph is made up of a semicircle and a line segment.
Write the equation.
This is the graph of y equal f of x. Okay. And then they're going to define a different function. Now they're going to say g of x is the integral from 2 to t, 2 to x of f of t dt. Okay, so this is the questions they're going to ask. At what value or values of x does g have a local maximum, b local minimum, and c, you can probably guess, point of inflection.
Oh, I got the point of inflection.
Okay, now, thinking back to the last chapter, how do we compute maximums, minimums, and points of inflection? You find, well, for maxes and mins, what do? You compute the first derivative and then you make a number line. We're not going to do anything different. How do we find points of inflection? We compute the second derivative and make a number line. That's what you got to do. It's just the information is given in a different form. So this is what g is. So how do I find, oh, I'm sorry, we have to do some preliminary problems too, I forgot. Okay, before this, we also have to compute the following values. G of -2, G of 0, G of 2, and G of 4. Compute these four numbers before we even get started. Okay, if this is the G function, how do you compute G of -2? What do? You plug in -2 for x, so plug in -2 for x right there. So you get the integral from 2 to -2 of f of t dt. Yeah, but Mr. Park, the smaller numbers stay on the top. Well, switch it. If I switch the limits like this, what's gonna happen? Yeah, you gotta negate the value. Oh, you gosh. Ah! Okay, now, what does this integral represent? Gosh, I boxed them up. So what happens when you get old?
Graph.
Okay, here is the graph of f. What does the integral from -2 to 2 tell you? The area between the graph and the x-axis. So here's -2 and 2. What is that area? In fact, you did a lot of this on today's quiz, so you just know already.
2 pi.
2 pi. But there's a negative sign, so the answer is -2 pi. Now I'm going to tell you right now in the AP exam, each one of these is either 0 or 1. You missed that minus sign, you got 0. You got the same score as somebody in Mississippi drawing pictures on their paper. That's the way it is. Okay, now how do I compute G of 0? Plug in 0 for x right there. You get the integral from 2 to 0 of f of t dt. Yeah, but Mr. Park, the smaller numbers stay at the top. Well, switch it. But what happens when you switch the limits? You gotta negate the value. Now, what does this integral represent? If this is the graph of f, it represents the area from 0 to 2. Here's 0 to 2, that means this area right there. That's 1/4 of a circle. So the answer is -pi. Are you guys following? Okay, now, G of 2, this is the easiest one. What happens when I plug in 2 for x right there?
0.
You get the integral from 2 to 2 of f of t dt, and what is that equal to? 0, right? Because anytime you do any number to itself, that's one of the properties of integrals. And then finally, plug in 4. The integral from 2 to 4 of f of t dt is the area from 2 to 4. Well, here's 2 to 4. What's this area right there? It's a triangle. 1/2, 2 times 2. 2. Okay, so can everybody do that? Because we're actually going to use it in this problem. So now, how do you find where you have local maxes and mins? You take the derivative and you make a number line. Now, how do I take the derivative of an integral from a constant to something? That was the lesson from last time. What do you use? What are we going to use?
The first part of the fundamental.
Exactly. It's called the Fundamental Theorem of Calculus, Part 1. So the first thing you got to do is you got to make sure the bottom limit is a constant, is it?
Yes.
So all you have to do is take that thing and plug it in there, and you get f of x. And then the most important part, you got to times it by the derivative of that,
1.
which is 1. It's not always going to be 1, but in this problem it is. So what did we just learn here?
First derivative.
The first derivative of g is equal to f. That means this graph that's drawn over here is the first derivative. So if you make a number line for g prime, you're simply making a number line for f, which is this graph over here. What goes on the number line? When does this graph touch the x-axis? At -2 and 2, and then it's above, and then it's above. So what does that mean? G is, remember doing this? G is increasing some more. So, where do you have a local maximum? Is 2 a local maximum? Is it a min? No. So where do you have the local maximum?
4.
At the end point, right there, at 4. So local max at x equals 4. In fact, we can clearly see that that's going to be the absolute maximum, right?
Yeah.
And then where do we have a local minimum? On this end point over there, at x equals -2. In fact, that's going to be the absolute minimum, right? Because the graph just starts there and it just keeps going up. Now, where do you have points of inflection? How do you find points of inflection? You compute the second derivative and you make a number line. So if the first derivative of g is f, what's the second derivative of g? F prime. So what you need to do, if you're going to make a number line, is you have to make a number line for the derivative of this graph, or the slope of this graph. You did it on the last test, so what are you looking for? where is the slope either 0 or doesn't exist?
0.
Yeah, right there, and then right there, because sharp point, yeah? So on your number line, you should have 0 and 2. Okay? So, from -2 to 2, look, the graph is going uphill, so what can you say about the slopes? No, they're positive, they're positive. From 0 to 2, what can you say about the slopes? They're negative. And then from 2 to 4, it's positive. What do I need to write underneath this? G is concave up.
Just make a
G
legend.
is concave down. G is concave up. So, is 0 a point of inflection? Does it change concavity there? Yeah, what about 2? Yeah, so a point of inflection at x equals 0 and 2. This is how you do this problem. You're going to get 2 of those on tonight's homework. You're going to get 1 on the practice test for practice, and then on next week's test, you're going to have a good one. You're going to have a good one for you. But look, if you just go back to what you know how to make number lines. Take the derivative, make a number line. Take the second derivative, make a number line, you can answer all the questions. Yoshida. No. Yeah, okay, you can. But remember, when you on the free response, the answer is only worth 1 point. The work is worth 4. You know, I mean, if you want to get 1 out of 5 points, then you're on track for a 2. You're on track for a 2 on the AP exam. You gotta show your work. Who?
2 is not a
At 2? Because look, if the graph goes uphill and it goes uphill some more, that's neither a max or a min, right? In order to have a minimum, your number line gotta be minus plus. It's gotta decrease and then increase, right? But this is increase and increase some more. So that's neither a max or a min. Remember, just because the derivative is 0, that doesn't mean it's a max or a min. You have, that's why you, is that my calculator?
I think so.
Sorry.
Does it still work?
Yeah.
Of course.
Oh, yeah.
Because it got turned on when you dropped it. Give me that thing! How dare you?
This is big.
Okay, any questions on this?
The calculator?
Okay, so you know what's gonna be happening as we go along? The antiderivatives are gonna get harder and harder. Just for that, we don't have time to watch the movie already. Okay, I'm gonna give you the next level of antiderivatives. Because some of you think you're good, yeah?
Yeah.
Okay, so here, antiderivative. I give you the derivative. Here, you know what? Let's write it like this. I give you the function, you tell me the antiderivative.
Can we make this again?
Okay. You guys think you're good, yeah?
Yeah.
Here we go. E to the x. Okay, whose turn is it? Kanashiro. What's the antiderivative? Because how can you compute an integral? You gotta know your antiderivatives, right? And believe me, on the next test, I'm gonna test you on all of them. You got an easy one. Moriguchi's gonna get the hard one, huh? Close. E to the x. No, plus. Oh, your voice changed. Don't forget the plus c. If you don't put the plus c, you're cruising for a 4 on the AP exam. Okay, now Moriguchi. E to the 2x. What is the antiderivative?
E to 2x, or 2e to 2x. Let's see.
Okay, let me ask you this. If I take the derivative of this, will you get that?
Oh, I did the opposite way. 1/2?
Okay, very good. 1/2. Yeah, you cannot get mixed up between derivative and antiderivative. Does everybody know why there's a 1/2 there?
Yeah.
Because the derivative of e to the 2x is e to the 2x times 2. That's why you need a 1/2 to cancel out the 2. So that means when the derivative of the box is a constant, you have to adjust for the constant. You know what I'm talking about? Okay, next, cosine 3x. Angelo.
Should be sine of 3x plus c.
Is it just sine of 3x plus c? No, because I left the space in front. 4.
Oh yeah, 1/3.
There you go. Does everybody see why you have to have a 1/3 there? Because the derivative of sine 3x is cosine 3x times 3. You need that 1/3 to cancel out the 3. Everybody's following?
Yes.
Okay, Lee, sine 4x. What's the antiderivative?
Negative 1/4 cosine 4x plus c.
Hey, you guys are getting the hang of it. Secant squared 5x. Whose turn is it? Hui. When you take the AP exam, what gonna be there? Go. Don't write that on your paper. Don't write it on your paper. Tangent 5x. Hey, we're getting the hang of it. Cosecant 6x, cotangent 6x. Who?
Negative 1x. Secant 6x.
Yeah, we're getting the.
We're getting the hang of it. You guys think you're good yet?
Yeah, we think we're good.
Okay, now, this is the last problem. Yoshida, if you get it, we're done. If you don't get it, we're gonna keep on going. That's not the last one. You guys think you're good, yeah?
Yeah.
You think you're good?
Yeah.
Can we stop it?
Dude, this just.
Oh, it's over.
This is AB.
Okay, now, wait, look. If it was 1 over, okay, look. Let's call it the next person. Owen, 1 over x squared plus 1. I'll give you a hint. Something plus c.
This is too much. Oh yeah.
Okay, it's right on the. It's off the list. It's like you don't even have to think. It's on the list.
Tan inverse.
Okay, tan inverse x plus c. Okay, but okay, Yoshida, you're up here. What if I go x over x squared plus 1? And please do not say x tan inverse x, because that's not right.
Hey, Joe and I.
You guys, can you see why x tan inverse x is right? If I take the derivative of this, you gonna get that? No, because you would have to use the product rule, and it's not gonna look
Yeah,
anything
you gotta
like
use
that,
the
right?
quotient rule.
Okay, this one, it takes
oh,
thought.
okay.
This one you gotta really think of it. It's not as easy as some of you think it is. Choi, you think you got it? Why not? Okay, give me a guess. Huang, you're next. just laugh it off. And you'll skip over me. Lao? Olga, you were showing somebody something.
Negative natural log.
Oh! Okay, wait. Negative, natural log. I'm telling you, the antiderivatives get tougher. Okay, I'll give you a hint. There is natural log in it.
You're supposed to flip it, then separate, and you have like.
Oh, I see.
Okay, Yoshida, you got it yet?
So it's.
Who thinks they got it? Lao? Hui? Abe?
Can I just guess?
Yeah.
Just guess.
Yeah. No, I mean like educated guess.
Okay. Like reciprocal
What?
of that inside the element.
Okay, I'll give you another hint. Okay?
So x squared over. Yeah.
Yes.
Yeah, that's what I meant.
There, that's the antiderivative. Now somebody going, what?
Why though?
Because look, if this is indeed the antiderivative, if I take the derivative of it, shouldn't you get this?
That was wrong.
Oh yeah.
Okay, so what's the derivative of that? You throw the 1/2 on the side. What's the derivative of natural log box? 1 over box times the derivative of box. The 2's cancel out, and bam, you got that. Wait. Mr. Park, I give up. No! So that means you have to know the easy ones so that you can do the harder ones.
I don't think.
You
I'm
know
good
what?
anymore.
Just because of this class. Speed quiz on
No.
No.
No,
no.
It's too.
Wait.
On what, on all of them?
Speed quiz on the basic integrals.
The easy one.
What are basic?
What a basic.
The ones that are on the list.
All of them?
Even
Okay.
the last one.
Did you get, what?
Even the last
No,
one.
the last one is not basic.
Oh, okay.
No, the list and.
Okay, the
one
list,
the
okay.
website.
All I
Next to
want you
the
guys to do is
derivative.
go, here, let me give you a sample, the bell's gonna ring already, like this. Integral, did you guys print out the list yet? That's on the website?
Yeah.
There's a list on the website?
There's one.
Screensaver.
Secant U, tangent U, du.
Wait, but we didn't go over some.
Yeah, we didn't do some of them, that's right. You know what, I changed my mind, no quiz.
Yes!
Why should I have to suffer and spend my time correcting?
I can correct
But
for
we
you.
can just suffer on the test.
Yeah, you just suffer on the test, get fatal errors left and right.
Good idea. Wallpaper.
My life is just one big thing.
Yeah.
Yeah.
Darn, I put that video in for nothing.
All the time.
The moment you wake up, you just see